Amid the layered mountain ranges and the complex urban network of Chongqing, a massive infrastructure megaproject has taken shape. Chongqing East Railway Station. This project cost more than $8 billion, covers an area of over 1 million square meters, and is 3 times larger than Nagoya Station in Japan, which was once recognized as the largest railway hub in the world. And it was completed in just 38 months, a construction speed that is almost impossible to achieve in most cities. More than just a high-speed rail station, this structure has been designed as a multi-level transportation hub capable of connecting millions of passengers every year. In this video, join Mandarin Tech as we explore how China built one of the largest and most advanced railway complexes in the world. Chongqing is one of China's largest centrally administered municipalities, with a population of over 30 million people, comparable to that of many developing countries. Its residential areas are separated by deep valleys, steep hills, and major rivers, creating a highly layered vertical landscape. Because of this terrain, operating and constructing infrastructure in the city has always been extremely challenging. Expanding road and railway systems here requires overcoming major technical and financial obstacles. Currently, Chongqing has 3 major railway stations, and the primary hub, Chongqing North Railway Station, has already reached its capacity limits and is not well positioned for further platform expansion. At the same time, China is planning and building the world's largest high-speed rail network, structured around 8 north-south corridors and 8 east-west corridors, connecting all major metropolitan centers across the country. Located at the heart of southwest China, Chongqing has become a critical node in this national strategy. As a result, local authorities decided to construct Chongqing East Railway Station. This project reflects a broader urban development strategy aimed at shifting economic activity and infrastructure toward the eastern part of the city, helping reduce pressure on the already crowded central districts. Construction of Chongqing East Railway Station officially began in 2022. From the very first day, the site no longer resembled a traditional construction site. Alongside thousands of workers, a completely new force appeared. Construction robots, automated systems, and equipment controlled by artificial intelligence. Instead of relying entirely on human labor, China adopted an industrialized construction model where machines handle most of the heavy work and tasks that require high precision. The process began with excavation and ground leveling. However, leveling the terrain here was far more complex than in flat regions. The ground in Chongqing is a mix of hard rock and weak soil layers, forcing engineers to constantly adjust construction methods for each specific area. Automated bulldozers, equipped with laser positioning systems and GPS, operated around the clock, creating a foundation surface accurate down to the millimeter. This level of precision is critical because even a small deviation at the foundation level could affect the entire massive structure above. With summer temperatures often exceeding 40 degrees Celsius, working conditions became extremely harsh. But unlike humans, automated systems maintain stable performance without interruption. Once the leveling process was completed, the ground reinforcement phase began. Engineers used deep piling methods combined with concrete reinforcement to ensure the foundation's load-bearing capacity. Thousands of concrete piles were driven deep into the ground, passing through weak geological layers until reaching stable bedrock below. This was a crucial step, allowing the structure to remain stable on naturally unstable terrain. After that, concrete was poured to form the foundation base. Specialized robots handled distribution, leveling, and real-time monitoring of the concrete's uniformity. The result was a foundation that is not only structurally strong, but also built with extremely high precision, a key factor for all the construction stages that followed. Once the foundation was completed, the project began to rise above the ground. The main structural components of the station were built at high speed through a combination of human labor and advanced machinery. A massive steel framework was gradually assembled, forming the skeleton of the entire station. These components were enormous, weighing tens to hundreds of tons, and were transported and installed using heavy lift cranes. Instead of building everything piece by piece on-site using traditional methods, many structural elements were prefabricated in factories and then delivered for assembly, a method that significantly reduced construction time. One of the most complex stages was the installation of the glass facade, which was supported by specialized robots. Glass panels weighing hundreds of kilograms were transported, precisely positioned, and installed with extremely high accuracy, while also minimizing risk for workers. With the help of Building Information Modeling, BIM, the entire construction process was digitally simulated and coordinated before execution. This allowed engineers to reduce errors and optimize the overall schedule. As a result, the project was no longer built in a linear sequence. Instead, multiple sections were constructed simultaneously, turning the site into a massive, continuously operating system that functioned almost without pause. More than just a single station, Chongqing East Railway Station is designed as a strategic hub within China's national high-speed rail network. The station directly connects to multiple major railway lines, allowing passengers to travel quickly to key economic centers such as Chengdu, Guangzhou, Shanghai, and Beijing within just a few hours. This transforms Chongqing into a major transit gateway in southwest China. Beneath the station lies a multi-level rail system with dozens of tracks and platforms. High-speed, inner-city, and urban rail lines are separated, yet still efficiently interconnected. This design helps optimize train flow and significantly reduces congestion. In addition, the station is fully integrated with metro systems, buses, and other urban transport modes, forming a multimodal transportation hub. Passengers can transfer between different types of transport without leaving the complex. The control system uses artificial intelligence to analyze traffic flow and coordinate operations in real time. As a result, hundreds of trains can operate each day with near-perfect precision. Beyond scale and operational efficiency, Chongqing East Railway Station was designed with a high level of aesthetic sophistication, reflecting the fusion of engineering and art in modern architecture. The entire structure draws inspiration from Chongqing's mountainous landscape, featuring flowing curves and expansive open spaces that create a sense of continuity and natural harmony. The wide roof is supported by tree-like steel columns, which not only provide the strength needed for the massive structure, but also give the interior a light and airy atmosphere. Inside the station, natural light is maximized through large glass systems, reducing the need for artificial lighting and creating a more comfortable environment for passengers. The space is designed based on a human-centered philosophy where the user experience comes first. Movement within the station becomes more intuitive, with fewer direction changes and significantly reduced wayfinding time. As a result, the station is not just a transportation hub, but a modern public space where functionality and user experience are seamlessly integrated. Chongqing East Railway Station is not just a transportation project. It is also the center of a large-scale urban development strategy. The eastern area of Chongqing, where the station is being built, is being planned as a modern urban district with a full range of functions, including commercial spaces, offices, residential areas, and public services. The station acts as the core, attracting both people and investment into this region. This model is known as transit-oriented development, where transportation infrastructure becomes the main driver of urban growth. With fast connections to major cities, the area surrounding the station is expected to become a new economic growth hub. This development not only helps reduce pressure on existing central districts, but also reshapes the overall urban structure of Chongqing. From a city once divided by challenging terrain, Chongqing is gradually transforming into a modern, highly connected metropolitan center. When completed, Chongqing East Railway Station will not simply be a new station, but a turning point in how the entire transportation system of Southwest China operates. With its massive scale and high level of integration, the project significantly increases passenger capacity while reshaping the connectivity between major cities. Millions of passengers each year will benefit from a system that is faster, more seamless, and more efficient. Journeys that once took many hours or required complex transfers are now significantly shortened, enabling stronger flows of trade, labor, and tourism. The station is no longer just a destination, but a critical link in the region's economic value chain. At the same time, the project brings clear economic and social impacts. The construction and operation of the station create thousands of direct and indirect jobs, stimulate the real estate market, and accelerate the formation of new urban areas nearby. Businesses, investors, and capital are gradually shifting toward this region, transforming it into a new growth hub for Chongqing. More importantly, this project clearly reflects China's long-term strategy to expand and upgrade transportation infrastructure on a national scale. When placing Chongqing East Railway Station alongside iconic projects such as Grand Central Terminal, Grand Paris Express, and Nagoya Station, the difference lies not only in scale, but also in the speed of execution. Grand Central Terminal in New York is one of the most famous railway stations in the world, completed in 1913 after more than a decade of construction. It is not only a transportation hub, but also a cultural and architectural symbol of the United States. However, what stands out is that Grand Central was not built in a single phase like modern megaprojects. Over more than a century, the station has undergone multiple renovations, upgrades, and expansions to meet the growing needs of the city. This represents a gradual development model built over time with continuous adjustments. While it ensures quality and alignment with the urban environment, it also means the process can take decades to fully evolve. In France, the Grand Paris Express is considered one of the largest metro expansion programs in Europe, with more than 200 kilometers of new rail lines and dozens of modern stations planned around Paris. Yet despite being launched in the early 2000s, the project is still under construction and is expected to continue into the 2030s. This is largely due to strict environmental regulations, complex procurement processes, and the involvement of multiple stakeholders. Each phase must go through detailed evaluation, from environmental impact assessments to public consultation. This ensures sustainability and transparency, but also significantly extends the timeline. In Japan, Nagoya Station was once recognized as one of the largest railway stations in the world, highlighted by the JR Central Towers, a complex integrating the station with retail, hotels, and office spaces. Its development took place over many years and was carried out in carefully planned phases. Japan follows a cautious approach, prioritizing precision, safety, and operational efficiency over construction speed. Its railway system is known for near-perfect punctuality, and any upgrade must ensure that existing operations remain uninterrupted. As a result, expansion is carried out in small, controlled steps, rather than through rapid, large-scale construction. These comparisons highlight an important reality. There is no perfect model of development. While Western countries and Japan prioritize transparency, long-term stability, and sustainability, China stands out for its speed, scale, and rapid execution. This difference is not only about technology, but also about organization, political systems, and development strategies. And it is precisely this contrast that is shaping a global debate about the future of infrastructure. Between speed and caution, between immediate efficiency and long-term sustainability. From a region once divided by mountains, deep valleys, and powerful rivers, Chongqing is gradually redefining itself as one of the most advanced transportation hubs in China. But what makes this transformation remarkable is that it is not driven by luck. It is the result of strategic decisions, advanced technology, and the way people choose to confront the limits of nature. Chongqing East Railway Station stands as the clearest example of this shift. It is not just a railway station, but a system designed to connect, to accelerate, and to reshape how a modern city operates in the 21st century. Every train departing from here carries not only passengers, but also the flow of economic activity, opportunity, and growth. But an important question remains: is this speed an absolute advantage, or does it come with trade-offs that are not yet fully visible? Could this become the model that cities around the world choose to follow? Let us know your thoughts in the comments below. And don't forget to subscribe to Mandarin Tech for more stories about technology and the mega projects shaping the future of our world.